Organizing, visualizing, and describing data. In this reading, we will look at different types of data. So, for example, we can have structured data versus unstructured data. We will look at how to organize data for quantitative analysis. We will look at how to summarize data using different types of frequency distributions. We will also look at how to summarize data using a contingency table. We will talk about data visualization. Then we will move on to measures of central tendency. This includes mean, median, and mode. So basically, measures of central tendency give us some sense about the data that we are looking at. We will look at quantiles. So here, for example, we can have quartiles, percentiles. This involves sorting data and then organizing into quarters or fifths. When we organize data into quarters, then that's called quartiles. Section 9 deals with measures of dispersion. This has to do with how spread out the data is. While measures of central tendency tell us the average value or the median value, measures of dispersion tell us whether the data is very spread out or not. Then we will talk about downside deviation and the coefficient of variation. With the coefficient of variation, we combine the concepts of central tendency and dispersion. Then in section 11, we will look at the shape of distributions. At a very basic level, a distribution might be symmetric, which means that there is a similar looking distribution above and below the mean, or sometimes distributions can be asymmetric. And then finally, we will talk about the correlation between two variables. With respect to data types, the first key question is, what is data? Data is a collection of numbers, characters, words, and text to represent facts or information. Data can be in a raw format or an organized format. When we talk about data types, there are three broad classifications. We can look at data as either numerical or categorical. Another categorization is where we look at data as cross-sectional versus time series versus panel. And then we can look at data as either structured or unstructured. Let's start with numerical versus categorical data. Numerical data is also called quantitative data. This is where values represent measured or counted quantities as numbers. Numerical data can further be classified as continuous data or discrete data. So, for example, if we say that here is a certain investment amount, and then we ask the question, what is the future value of this investment amount? Clearly, the future value will be numerical, and this could represent a whole range of possible values. These values, which represent the future value of the initial investment amount, spans a continuous spectrum. Therefore, we say that this is continuous data. On the other hand, if we are talking about discrete compounding, and we say that in a given year, we have, let's say, 4 compounding periods, or if we say that the compounding happens monthly, in which case we have 12 discrete compounding periods, then the number of compounding periods can be referred to as discrete data. So the central point here is that with discrete data, data is limited to a finite number of values. So with discrete data, we have finite, whereas with continuous data, we have an infinite number of values. Moving on to categorical data, which is also called qualitative data. Categorical data are values that describe a quality or characteristic of a group of observations. Generally, with qualitative data, we will have a limited number of values that are mutually exclusive. Under qualitative data, there are 2 sub-categorizations. We can have nominal data and ordinal data. With nominal data, we have categories where a given category isn't necessarily better or worse than the other. So for example, if we are looking at a universe of stocks and we divide them into different sectors such as the energy sector, the industrial sector, the pharmaceutical sector, and so on, this is a nominal categorization because we won't say that energy is better than industrials and so on. So we are basically giving names to different sectors, and that's where the term nominal comes from. So think of nominal as basically giving names to different categories. Then we have ordinal data. Here again, we have categories, but the categories do have an order. For example, if there is a mutual funds rating, we are looking at, let's say, 100 different mutual funds. The worst performing mutual funds get 1 star. Then funds that are better than that get 2 stars. Then we have 3 stars, 4 stars, and up to 5 stars. Now, clearly, a fund that gets a 2-star rating is better than a fund that gets a 1-star rating. In other words, the 2-star category is better than the 1-star category. But with ordinal data, we can't say how much better. So we can't say that the 2-star category is twice as good as the 1-star category. Or if we have a 3-star category, we can't say that the 3-star category is 3 times better than the 1-star category. So with ordinal data, there is an order, but the relative difference between orders is not really meaningful. All right, so let's look at a practice problem. I want you to identify the data type for each of the following items. So here you will need to use the data types that we've discussed so far. So we can have discrete versus continuous data, and then we can have ordinal versus nominal data. So with these 4 data types, you need to figure out which one is appropriate for each of these items. The number of coupon payments for a bond. The correct answer here would be that this is a discrete data type because there is a specific number of coupon payments. And obviously this is numerical. So discrete versus continuous is numerical. Ordinal versus nominal is categorical. Next, we have dividends paid by a stock. This is numerical, and under numerical, it is continuous because the dividends paid can span effectively a continuous range. Next, we have credit ratings for corporate bonds. Now, there are different credit ratings such as AA, AAA, and so on. So clearly, those are categories, and the order does matter. So AAA is better than AA, but we can't say how much better. Similarly, AA is better than A, but we can't say that AA is twice as good as A. So this is categorical and it is ordinal because the order does matter. Then we have hedge fund classification types. So there are different hedge fund classifications, as we will see in the segment on alternative investments. And just like I described earlier, where we can have stocks in different industry sectors, the different industry sectors represents a nominal classification. Similarly, the different hedge fund classification types represent a nominal classification because we can't say that a particular hedge fund type is better than the other. So this is a nominal classification. Moving on to cross-sectional versus time series versus panel data. This classification is based on how data are collected. And before we dive into the specifics of time series, cross-sectional and panel data, let's understand the concept of a variable and an observation. A variable is also called a field or an attribute or a feature. This is a characteristic or quantity that can be measured, counted, or categorized. A variable is a characteristic or quantity that can be measured, counted, or categorized, and a variable is subject to change. So, for example, if we are studying Microsoft stock, the return of this Microsoft stock in a given quarter can be considered a variable. And then an observation is a specific value of this variable. So we can say that in 2019 quarter 1, the return was 3%. So the 3% represents a specific observation. Therefore, we can say that the observation is the value of a particular variable collected at a point in time or over a specified period of time. Now let's look at the classification. With time series data, we look at data over a particular period of time. Now let's look at these three categories. Time series data consists of observations for a single subject taken at specific and equally spaced intervals of time. So let's say that we are talking about Microsoft stock and we are concerned about quarterly returns. We can say that for Microsoft, the quarterly returns in 2019 are reported. So we'll have quarter 1, quarter 2, quarter 3, and quarter 4. So if we say that in these 3 quarters, the return was 3% in quarter 1, 2%, then minus 1%, then plus 5%. So this represents time series data because for a single variable, we have taken the observations over a period of time. And notice that these time periods are specific and equally spaced. Cross-sectional data consists of observations for multiple subjects taken at a specific point in time. So now let's say we are comparing Microsoft, Oracle, and HP. With cross-sectional data, we will take a specific period in time, such as 2019 quarter 1, and then we will look at the returns of 3 different stocks. In this period, let's say Oracle was 2% and HP was 4%. So this would represent cross-sectional data. And then we have panel data, which is a combination of time series data and cross-sectional data. Panel data is generally represented as a table. Continuing with this example, if we also now have the time series data for Oracle and HP, so let's say Oracle then produced 3% in quarter 2, 5% here, and then minus 2% here, and then we fill out the data for HP. So this table essentially represents panel data because it is a combination of both time series data, which effectively is vertical in my example, and cross-sectional data, which is horizontal in this example. Data can also be categorized as structured versus unstructured. Structured data is highly organized in a predefined manner, usually with a repeating pattern. It is easy to enter, store, query, and analyze without much manual processing. An example of structured data is market data, where for a given market, we can have different securities such as A, B, C, D, and then for each security, we might want to keep track of the closing price. So closing price of A on day 1, day 2, day 3. So we will have all days of a given month. And then with month 2, again, we will have day 1, day 2, day 3, and so forth, and so on. So notice here that structured data is usually stored in the form of rows and columns. So effectively, we have tabular data. This data will generally have a repeating pattern, and notice that it's very easy to put data into such a format and to pull data or query data from such a format. Other examples of structured data would include fundamental data, which is the data contained in financial statements such as earnings per share. Even analytical data would generally have a structured format. So for example, if we come up with cash flow projections for different companies, that would be stored as structured data. Unstructured data, on the other hand, does not follow any conventionally organized format or form. This data is generally collected from unconventional sources. There are many different examples of unstructured data. For example, data that is produced by individuals. Individuals might post social media comments. There might be data related to website searches. So this sort of data would classify as unstructured data. Also, data that is generated by business processes, such as credit card transactions and corporate regulatory filings, would be considered unstructured data. The data that is generated by sensors, so for example, satellite images or foot traffic by mobile devices, would also generally fall under the category of unstructured data.